We're going to prove a theorem that's really easy to prove if you know you're in a Euclidean geometry. And what you'd really like to use is the fact that the angle sum of a triangle is exactly 180 degrees. But we can't do that. We have to try to prove for an arbitrary triangle that an exterior angle is greater than the measure of either non-adjacent interior angle. Okay, so we're going to extend line or segment BC out to D. And what we're trying to show here is that the exterior angle has greater measure than either remote interior angle. So we're not actually doing the proof for both things right now. We're just focusing on A. We also have to prove this for B, but the proof works the exact same way, except I extend to the point D over here. So I left that part off. I just did the angle A version. Okay, so the first thing we do is create the midpoint here between A and C. And then this is one of those where the construction is everything. If you don't know how to create this construction, the proof is nearly impossible. And so what we're doing now is we're extending the segment BM out to a point E to make sure that the point E is exactly the same distance away from M that B is from M. And then by construction, we know that since M is the midpoint, we know that BM is equal to the distance ME and AM is equal to the distance MC. Which means that we have, after we get the vertical angles congruent, we have SAS congruence. I add the line segment ECN, and then make sure that you know this, that you have to label your triangle congruence in the right order. So this triangle congruence says AMB, right? So AMB, and we have to go in the correct order, right? So this line segment first, so I need to go CME. And I actually got this wrong. I'm gonna have to change this. I'll go into the file and change this. This is actually, oh wait, angle is fine. The triangle is right. Yes, triangle EMC. And notice that I don't have congruent triangles. If I go EM, which is the first line segment here, right, is not congruent to AM. So I'm gonna have to go in and change this to triangle CME. Sorry about that mistake. Funny that it happened when I was creating a pro tips video. Now, what's going on here? Well, we have congruent triangles, and so by definition of congruence, corresponding parts of congruent triangles are congruent, and that's what CPCT is an abbreviation for. Congruent parts of congruent triangles are congruent. So what we're saying here is that, right, I know that this angle alpha prime corresponds to this angle alpha because we have congruent triangles. All right, and then our last statement is pretty straightforward. We're trying to claim that the exterior angle is larger than the interior angle. Well, the exterior angle is the sum, its measure is the sum of an angle that's the same as A prime, alpha prime, right, plus another angle, right? So here I have angle alpha, the measure of angle alpha plus the measure of angle beta. Well, the measure of angle beta has to be bigger than 0. That's the only way for this not to be the case, right, is if I collapsed A all the way onto the line. So as soon as I have any kind of triangle at all, then that then angle beta is non-zero, it's positive. Well, angle measure always has to be 0 or positive, has to be non-negative. And therefore, I can just use substitution, right? Since we know that angle alpha and angle alpha prime are congruent, their measures will be the same, so I can swap that in, right? And I know that the measure of angle ACD, which is the exterior angle, is larger than the measure of the angle at A, there, alpha prime. And again, except for a naming problem on my triangle congruence, that completes half the proof, right? So the other proof would say that this exterior angle is greater than this. Well, okay, what are we going to do? Well, we'll extend the triangle this way, and then this will be the angle that needs to be, that we'll be able to show using the same exact proof. It's bigger than the angle here at B, but notice that it's a vertical angle to the one we just proved. So we will actually get it, right, by just creating this, um, you know, down here to a point D prime, and we can complete the proof that way. So it's true that the measure of an exterior angle is greater than the measure of either non-adjacent interior angles.